So today we are going to talk about lesson 1-2, which is function operations. So the question is, what's a function? So we're going to review what a function is. So from Algebra 1, you need to remember that a relation is a set of ordered pairs. So that would look like 1, 2, 3, 4, 5, 6, 7, 8, or it could look like 1, 2, 1, 4, that's a 4, shocking, 2, 6, and 3, 8. So one of these two right here is a function and one is not. So a function, you can look at it two different ways, because essentially all functions are relations, but not all relations are a function, because they have to pass a certain test. Actually, there's two tests you can apply to determine if something is a function. So when you're looking at a relation that's a set of ordered pairs, remember that a set of ordered pairs can be a table of values. It can be, I could plot these points on a graph, so it could be an actual graph. So if I'm looking at a set of ordered pairs or a table of values, I can apply the first test. And the first test would be the x value does not repeat. So the x value, that's an E on the x value does not repeat. The second test would be if I were looking at a graph, and that means that it's going to pass, or it passes, the vertical line test. I apologize that my writing looks like a kindergartner, but the way I have to write on here with a stylus, I can't put my palm down, so it always looks like I have kindergarten handwriting. So it passes the vertical line test. And I'll explain what that is again in a minute. So since these are not graphs, I'm not going to show you the vertical line test yet, but this one, if you look at the x values, 1, 3, 5, and 7, none of those x values repeat, so it passes this first test. So yes, whoops, I gotta move this. Yes, that is a function. Then the second one, if you look at it, look at this one and this one. So because those two values repeat, this one and this one, that cannot be a function. And in fact, if you graphed 1, 2, and 1, 4, they would be vertical to each other. And then if you tried to put a vertical line through them, it would touch that line more than once, which means it doesn't pass the vertical line test. So no, this one is not a function because the x value repeats. So then look at your next slide. And we're going to look at 3 graphs. Actually, let's look at this one first. I think this one is the one that's next for you anyway. So how do we write functions? So as I stated before, a function is a relation, and relations can be written as a set of ordered pairs. That can be a table of values, and they can be a graph. And then we have this thing called function notation. So this thing, function notation, is just this f of x here. So if I were going to graph this 3x plus 1, notice that in the past, this f of x has been a y. So you might have seen it written, so it looks like y equals 3x plus 1. So what does function notation mean? Notice that here, this f of x is the same as y, but this x here is what we call our input value. So I could have written, instead of f of x, I could have written f of 3. And what that would mean would be, if I wrote f of 3 in place of f of x, then the 3 is my input value, and I would want to put or replace each x that's in the function, the equation, with a 3. So if I replace this x with a 3, 3 times 3 is 9, plus 1 is 10, so my input would be 3, my output would be 10. So I would actually have the ordered pair 3, 10. So function notation just means that you've got another value, f of x is equal to y, where this is your input and this is your output. Then what does domain and range mean? So recall, again, from Algebra 1 that domain is the same as your x values. So if we were looking at this set of ordered pairs right here, if I were to name the domain properly, I'm going to do it up here, I'm going to name each of these x values, and I'm going to put them in order from smallest to largest, and if anything repeats, I am not going to repeat it. So my smallest domain value in that set of ordered pairs to the left, oh, don't you love my braces? Sorry, they were terrible. That's a little bit better. All right, so my lowest x value to the left there is a -3. Then my next lowest x value is a 0, and then a 2, and then a +3. So that represents my domain. Then my range would be my y values. So I'm going to take and look at each of the y values here. Now notice that the 4 repeats, so I'm not going to repeat the 4, I'll just write it once. And my smallest y value is this -2 here. So I'm going to start with range. Ooh, you can't even see that. I'm going to actually do my range in black so it'll show up. Range is equal to, again, my lowest range value was -2. Then comes 2, and then 4. So you can see that I have more values in my domain than my range, but that's okay. They're not meant to match up. Then let's look at, how do you know a relation is a function when you look at a graph? So we're going to apply the vertical line test. So as you can see here, it's asking you to apply that vertical line test. So you're going to apply a straight vertical line anywhere through these graphs to see if that vertical line touches the graph more than once. If a vertical line, as you move it across the graph, touches it anywhere more than once, it's not a function. So as you look at this first graph, isn't there a vertical line in the graph itself? So if I lay that vertical line over this black line, this blue line is over the black line, it touches this line an infinite number of times because it actually continues infinitely in this direction. Same thing here, I could have placed my vertical line here and it touches it in an infinite number of places. So this is not a function because it does not pass that vertical line test. So is it a function? No. Domain and range is a little bit more difficult. So we're going to start talking about domain and range. We talk about it a lot in Algebra 2. But remember, domain are your x values. So we want to start from our leftmost x value, which is your x-axis goes left and right. Your leftmost x value way out here is -infinity. There is no graph over here. So as I keep moving to the right from -infinity, the first x value I hit is this one right here. And that x value, if you look at the graph here, is -3. So, and then all of these ordered pairs on this line, every single one of them has an x value of -3. And then as I move across here, there's still no graph anywhere here until I hit here. And if I go up here, the x value here is +2. Every ordered pair on this line has an x value of +2. So in this entire graph, there are only 2 x values possible, -3 and +2. So you're going to write your domain, I'm going to try to write it small, as, those are your braces, mine are terrible, -3 and +2. Then your range, we're going to go, your range is the direction of your y-axis. So your range goes up and down. So my smallest y value is all the way down here, because remember, this keeps going infinitely in this direction. So there is a graph down here. It's this line all the way down here, and it goes on forever and ever. So your lowest y value, I can never find one, so that means it's -infinity. And then if I go up in this direction, I have a y value here, here, all the way up and up. It keeps going to +infinity. So that's basically all real numbers. And to show that, it would look like -infinity to +infinity. That's a little sideways 8. All right, look at the next graph. So this one, to determine if it's a function, I'm going to apply a vertical line straight through. It only hits it once. It hits it right there. Anywhere I put my vertical line, it only hits it once. No matter where I put this vertical line, it always only hits the graph once. So therefore, it passes the vertical line test. So yes, it's a function. Then the domain. We go left to right for the domain. So the leftmost value is way out here, right? So remember, this graph keeps going down and to the left, down and to the left, down and to the left, down and to the left. It will eventually cover the entire x-axis. And then same thing, as I go to the right, there's always a graph wherever I go, because this is going up and to the right. So up and to the right, up and to the right. It's going to cover the entire x-axis. So its domain is also all real numbers. So -infinity to +infinity. Then the range, our lowest range value, since this graph keeps going down and down and down, you're going to have -infinity all the way up. The graph keeps going up and up and up to +infinity. So the domain and range are identical. So -infinity to +infinity. The last graph is a circle. And as I put a vertical line through this graph, now if I put it through here, it only touches the graph once. But if I put it here, it touches it once, twice. So it touches it 2 times here. That makes it not a function. Touches it 2 times here, once, twice, 2 times here, 1 time here. So it only takes one instance of your vertical line touching the graph more than once to make it not a function. So no, this is not a function. Now let's look at our domain and range. This one's interesting. As I approach from the left, there's no graph over here, nor does it extend over here, until I come to here, and all of a sudden this is the leftmost part of the graph, right here, this little point right here. So if I bring that point down, let's see if I can bring it down, all the way to my x-axis, the leftmost x value is -2. There's actually an ordered pair right there where I put my point at -2, +2. So it's actually part of that graph. So my lowest x value is, oops, I don't want a parentheses. I'll explain why in a minute. You're actually going to have a bracket at -2. And the reason why you have a bracket is because -2 is included in that domain. Anytime we use -infinity and +infinity, we'll always have parentheses. If I only have certain values like here, we'll always use these curly braces. But if I want to give a range, like for instance, my x values go here from -2 all the way to here to +2. So there are x values from here to here. Mostly this part of the graph, you're going to have x values from -2 to 2. And this part of the graph, you're going to have x values from -2 to 2, and everything in between. Any decimal, any fraction, any number in between -2 and 2, there's going to be a y value. So because -2 and, here's the rightmost part of our graph, whoops, right there, and it goes to +2, that's going to show the range. It looks like an ordered pair, but it's not. So our domain is going to start at -2 and go all the way through any number you can think of until you hit +2. You're going to do the same thing for the range, but you're going to go from the bottom to the top. So the bottommost part of this graph is right here at +1, and it goes to the top part of the graph right here at positive 5. So from positive 1 to positive 5, you're going to have y values, and they are actual ordered pairs. So our range goes from our smallest value of positive 1 to our largest value of positive 5 with brackets. So we'll practice that more. You'll get used to it. All right, then let's start operations with functions. So we're not going to really write anything here. Basically, I just want you to understand that f plus g of x means you're going to add what we're going to call the f function. So you have a function that looks like f of x, and then they're going to call it a function of g, and it's going to have g of x equals something. So you're just going to take the f function and add the g function to it. The notation can be written this way or this way. Get used to understanding that it's either way. Same thing with difference. You're going to subtract. F minus g could be f of x minus g of x. If you have a closed circle, it means multiplication. So f times g of x means the function of f, or the f function times the g function. If we have a fraction, it means division. The f function divided by the g function. The only problem is, remember that that denominator in the fraction cannot equal 0. So we're going to have what are called restrictions. We're going to look at that denominator and determine what would make it 0, and that's going to restrict our domain because x, our input, is our domain. So let's look at the next set of slides. So I'm going to make these bigger so that we all can see them. That's a little bit better. There. So on this slide, we're going to add. So we've got this notation, which you need to be familiar with, and here is our f function. I'm going to underline that in blue. Well, I'm way off on my underline. Hang on. Let's try that again. I'm going to underline that in blue, and then hopefully that my green will show up a little bit. I'm going to underline that in green. Don't have too many options for this. So for this one, we're going to take the f function here and add it to the g function. So I'm going to use parentheses. So I'm going to take parentheses, my f function, which is x squared, minus x plus 2, and I'm going to add to that the g function, which is x squared, it's x squared, plus x minus 4. Sorry if that's hard to read. I don't have a lot of color choices. Equals. So technically you have a positive 1 here in front of the parentheses, and if you distribute that, nothing happens. So we can just drop parentheses and we're going to line up like terms. So I'm going to rewrite my f of x because nothing changes there. And then I'm going to line up the like terms, meaning the terms that have the same variable string for the g function right underneath the f function. So the g function has an x squared, it has an x, and it has a constant. And then you're just going to add these two together. And remember, when you are collecting like terms, the variable string doesn't change. You pay attention to the coefficients. So when I add my x squareds together, there's still going to be x squareds, but you're just going to add the coefficients. So 1 plus 1 is 2. So if I add 1x squared to another x squared, I get 2 x squareds. I don't get x to the 4th. That would be multiplying. So technically I have a 1 in front here and a 1 in front here. So again, 1x squared plus 1x squared is 2x squared. Now as you look at this one, I have a minus 1 and a plus 1. Don't they cancel each other out? So those are going to cancel out. And then a positive 2 and a negative 4 combine to give me a negative 2. So f plus g of x is equal to 2x squared minus 2. Now the second one here asks you to take the g function and add the g function to it again. So we're just going to go through the same process. I'm going to use parentheses. And my g function, unfortunately, is green. Sorry about that. So I've got x squared plus x minus 4. And I'm going to add to that in x squared plus x minus 4. And that equals, I'm going to revert to black so that you can actually read it. My first g is x squared plus x minus 4. I'm going to line up like terms. My second g is x squared plus x minus 4. We're just going to add those together. So again, pay attention to your coefficients. So my coefficients here are 1 and 1. So 1x squared plus 1x squared, 1 plus 1 is 2x squared. And then I have a 1 and a 1 here. So 1 plus 1 makes it 2x. Your variable string doesn't change. Negative 4 and negative 4 does not cancel out. You add and keep the sign. So g plus g of x is equal to 2x squared plus 2x minus 8. All right, look at your next slide. Now we're going to do subtraction. So the key with subtraction is, again, parentheses. So notice that you're going to take the f function and subtract the g function, or whatever they tell you to do. So here you do take the f function, subtract the g function from it. So again, I'm going to use parentheses. It's vitally important. So parentheses, my f is going to be in blue, and let's try the g in red. That'll show up better. So f of x is x squared plus 2x minus 3, in parentheses, minus x squared minus 3x plus 4 equals. So don't forget, look at this hint that I have over here. Hint, don't forget to distribute the negative. So remember, in front of here is really not just a negative, it's technically a negative 1. So there's this negative 1 in front, and you've got to distribute that negative all the way through. And essentially what that does is it changes the sign of every term here. So that becomes a negative, that becomes a positive, that becomes a negative. So your first function, the f function, doesn't change at all. So you still have an x squared plus a 2x minus a 3. Your second function, the g function, all the signs change. So you get a negative x squared, a positive 3x, and a negative 4. And so now we're going to add those together. Because the x squareds have opposite signs, you have a positive x squared and a negative x squared. They cancel. 2 plus 3 is 5. Your variable string doesn't change, so it's 5x. Minus 3 and minus 4 is negative 7. So f minus g of x is equal to 5x minus 7. Then we're going to reverse it. We're going to do g minus f. So same thing. I'm going to put a line here, and I'll move down into the bottom. So our g function this time comes first. So I've got x squared minus 3x plus 4 minus, and then our f function is x squared plus 2x, and then minus 3. Equals. So I'm going to do the rest down here below. So again, we really have a negative 1 in front of here, and we're going to distribute a negative into everything following that. So this entire function, they're all going to change signs. So you're going to have x squared minus 3x plus 4. That doesn't change. But then change all your signs in the f function. So you're going to have a negative x squared, a negative 2x, and a positive 3. And then we just add those together. So again, the x squareds have opposite signs, so they cancel. A negative 3 and a negative 2 gives you a negative 5x, because the variable string doesn't change. 4 plus 3 is 7. So you essentially have the opposite signs as the previous answer when you switch them around. So g minus f of x equals. Then let's look at multiplying. So multiplying, you just have to be careful because you're changing rules. So your rules for when multiplying like bases you are going to add your exponents. So for instance, if I have x squared times x cubed, that's equal to x to the 2 plus 3, which is x to the 5th. All right, so when dividing like bases, you are going to subtract your exponents. So for instance, we could have x squared divided by x cubed. Now when you subtract exponents, you have to subtract where there are more. In other words, there are more x's in the bottom, so we're going to cancel all of these out and we're going to do the subtraction down here in the bottom. So all of these cancel with 2 downstairs, so you end up with, if everything cancels in the numerator, you have a value of 1, not 0. 3 minus 2 is 1, so it becomes x to the 1st, which is 1 over x. Okay, and then we have x to the 5th. So we're going to apply those rules. So when you multiply, your variable string does change, and when you divide, your variable string is going to change. So with this the first one, f times g, so again, my f I'm going to make blue, and my g I'm going to make red. So I've got 2x minus 3 times my g, which is 3x minus 4. Then I'm going to double distribute or FOIL. So I'm going to take the 2x and multiply it to the 3x. Now you're going to multiply coefficient to coefficient, like base to like base. So 2 times 3 is 6. And then x times x, because you're multiplying like bases, you're adding the exponent. So 1 plus 1 is 2, so x times x is x squared. Then 2x times negative 4. So coefficient to coefficient, I've got 2 times negative 4 is negative 8. Then there is no other variable here, right here, to multiply that x. So you're just going to tack the x onto the negative 8. Then I'm going to distribute the negative 3 all the way through. So coefficient to coefficient, like base to like base. So negative 3 times 3 is negative 9. There is no variable here, so just tack on the x. So we get negative 9x, which is a like term to this one. So I've got negative 9x. I'm going to line those up. And then negative 3 times negative 4 is a positive 12. There are no like terms to that, so I'll give it its own column and then add down. So now we're combining like terms, so when we add down, we just focus on the coefficients. The variable string doesn't change. So we got a 6x squared, and negative 8 plus a negative 9 is negative 17x plus 12. So there's your answer. I'm going to move this over a little bit to look at this one. So this time we're going to take k times h. So our k, I'm going to put in, well, I'm going to put the h in blue and the k in red. So my k comes first, so I've got 2x minus 4 times my h is 2x squared. Now it really doesn't matter what order you multiply, so if you put the 2x squared in front, that's fine. Then we're going to distribute this 2x squared all the way into the parentheses. So coefficient to coefficient, like base to like base. So 2 times 2 is 4. And then x squared times x, that has an exponent of 1. So 1 plus 2 is 3. So I get x cubed. So 4x cubed. And then we have 2 times negative 4 is negative 8. So I have minus 8. And then we tack on that x squared. And then we're done. We have one more slide to look at. So let's look at quotients, which is dividing. So again, notice that when we divide, I have a hint. You've got to set the denominator equal to 0 to find your domain restrictions. So that's really important. And it's possible we might have to factor. So we'll just see. So we're going to take the f function and divide it by the g function. So my f function is in blue and my g function is in red. So I've got parentheses 2x minus 3 divided by parentheses 3x minus 4. Now you have to make sure that you fully factor your numerator, fully factor your denominator. So 2x minus 3 cannot be factored. There's no greatest common factor. It is not the difference of two squares. You have to be careful because you cannot cancel this x with this x. You can only cancel a 2x minus 3 with a 2x minus 3. You can only cancel a 3x minus 4 with a 3x minus 4. So this is your answer. It is fully reduced, but it's only part of our answer. So this is part of our answer. We have to find restrictions. We have to look at this denominator and determine what value for x would make this denominator 0 because the denominator fraction cannot be 0. So to find your restrictions, you're going to take your fully factored denominator, which in this case is 3x minus 4, and you're going to set it not equal to 0 because we don't want it to be 0. You just solve for x. So I want the x term by itself, so add 4. We end up with 3x does not equal 4. Divide by 3, and so our restriction ends up being x cannot equal 4 over 3. So that is part of your answer. You have to have that as part of your answer. So basically what that's going to do is restrict your domain. Your domain can be any value you can think of except for 4/3 because that's the only number that's going to cause a 0 on this denominator. So we can have any number, negative, positive, 0, fraction, decimal, except for 4/3. Okay? All right, last problem. We're going to take h and divide it by k. So h is in blue, h is in blue, and k I'll put in red. So h comes first, so I've got 2x squared, and since it's a monomial, I'm not going to put it in parentheses, over, then our k is 2x minus 4. So the numerator, a monomial cannot be factored. So the numerator cannot be factored, so it's going to stay 2x squared over. However, your denominator can be factored. I can factor a 2 out of the 4 and the 2. I can divide both 2 and 4 by 2, so that's the greatest common factor. So I'm going to pull a 2 out in front of parentheses, and then I'm actually going to divide this by 2 and this by 2. So here the 2's cancel, and I'm left with an x. And here the negative 4 divided by 2 is negative 2. So I get a minus 2. And now these two 2's can actually cancel. So these 2's cancel out, and your final answer is, well, nearly final, x squared over, I'm going to leave it in parentheses, x minus 2. But, so this is part of it, we have to find restrictions. So I'm going to find restrictions on my fully factored denominator. So we typically look at our factored denominator, which is right here, before we canceled, and any factor, so 2 is a factor, and x minus 2 is a factor. Any factor that has a variable in it, so this one can't cause a 0, but this one has a variable in it, it could cause a 0. So if we figure out what the value of x is, that would create a 0 here, because 0 times 2 would be 0, we have to restrict it. So let's find our restrictions. So I'm going to abbreviate this, restrictions. So we're going to take the x minus 2 and set it not equal to 0, and then we're going to solve. To get x by itself, you add 2. And so you end up with x not equaling 2. So then that has to be part of our answer. X cannot equal 2. And that's it. Good luck with your homework. Let me know if you have any questions.